thank you all for joining and for these panel discussions. I think this is personally, I believe this is one of the most important aspects of the industry, of the sector at large, because how can I say, let's use a little bit of a conversation tone. You guys are on the top of the food chain. Every decisions that the government and every policies that the government takes shapes what the developers do, and what the developers do shapes what the EPC contractor do, and what the EPC contractor do shapes what the manufacturer will develop. So right policy on the top of the, let's say, food chain influence at large what the sector is going to, where the sector is going to go. So I would like, if you agree, to see how the sector has been and how the policies that all of you have been trying to implement in your organization going to shape the address and the commitment that the GCC sector at large has taken towards a sustainable development. And I would like to ask first our guest coming from Saudi, I think it's as a matter of courtesy, Suleiman.
Assalamu alaikum wa rahmatullah. Good morning, everyone. If you allow me, I would like to start first by congratulating Dr. Corrado. This event has grown during the last 3 years, at least, when I've been here. The voice is okay?
Maybe, can you hear? Yeah.
Yeah.
Okay.
And I'd also like to thank the organizing team. This event has grown, at least during the last 3 years, from having the desalination focused conference to now having also stormwater. Very well done, Dr. Corrado.
Thank you.
Your leadership has shown the growth of this conference. Going back to your question, I think the demand is there. So when we talk about GCC region and the need for water, the demand is always there. You don't have sources for fresh water, so you would focus all your resources and your efforts on the desalination side. Having said that, there's also an effort that has to be done, not only to continue the desalination, but also have it as a more efficient vehicle going forward. So utilizing desalination in a better way, more sustainable way, a more cost-efficient way, a more energy reduced rate, and also continue the sustainability through the value chain. So you would focus upstream from going to the desalination side, but you now have a mature market, at least for the past 40, 50 years, and you need to focus more on creating policies to have it more sustainable and continue the process to treated water and reuse of this water.
Thank you. Thank you very much. I'd like to fire the same questions to also you, Kartik, and to you, Abdallah, to gather your reply. Whomever wants to intervene first is welcome. Abdallah, yeah, go first.
Thank you, Dr. Corrado, for the questions. Very valid. As my colleague stated very clearly, the water requirement is totally driven from the demand, and that the growth is happening, around different sector in our country. Of course, the customer being increased, and there is industrial requirement also for the water. Agriculture also, they are consuming a lot of underground water nowadays, and they are facing also challenges in order to secure that the water required, for their farms. So that's why everyone, demanding, water. From government, actually, there is a clear direction, that we have to focus in making sure that our reserve become, always resilient. So we are not losing, our reserve, and we have to find a way in order to have alternative solutions for the supplying the water. And the desalination, of course, is the only solution as of now. Going to olden days when we have the conventional thermal plants. It was used in the past, which served the purpose at that time, where were demanding a lot of electricity as well as product, and become as bioproduct at that time, for all the industrial area. Nowadays, with the introduction of the solar, renewable energies, it's become hard actually to continue with the same combination, and we need to do the decoupling. That's why we have forced through the system, through the regulation, through the standards, in order to find other way to decouple the water from the power. And here was government advising in order to go for another alternative, which is introduced, maybe widely in UAE and with big scale, the reverse osmosis technologies, where we are now investing in it. And of course, people now is not looking just, to have this technology, also to have the best efficient technologies as well. So technology is important to be more efficient, where the energy consumption will be less, good for the environment as well. It would not harm and impacting the environment, and serve the purpose in terms of supplying our customer with their demand. All the regulations and standards, even the direction and the initiatives from the government, is going toward, these directions, where it is giving us, the highlight and give us the incentive, and even the financial part, okay, which is supporting, the development for such, I would say, industry in the region.
Yeah.
Thank you.
Karthik, I like to pick up your thoughts about that.
Oh, thank you. Thanks a lot. Firstly, thanks a lot for inviting me to this session. Maybe to start with, when you talk about desalination, it's not something new across the globe, across this region. There are almost 21,000 desalination plants across the globe, around 150 countries. And I'm very happy and proud to say that this region has been pioneering the efforts of desalination. It's a collaborative efforts in terms of regulatory frameworks, in terms of public-private partnership, how things are shaping across in this industry. As TACA, we have a target of 1,300 MIGD by 2030, sustainable and energy efficient desalination. And as UAE, as Abu Dhabi, there is also a regulatory framework in place, and the risk mechanism is shared across various partners, be it the developers, be it the public-private partners, or be it even the procurer or the regulator. So the aim for all of us is to ensure that we produce an efficient solution which is sustainable. And
but one aspect that has been really correctly emphasized by Abdallah here is the retirement of the thermal desalination plant. I remember I have done a study whereby if we in the region, in the Emirates, I'm sorry, retire all the thermal desalination plant, this will be equivalent to the plantation of 3 billion trees, which is significant in terms of carbon capture, GHG avoidance. This is interesting because here I have two sectors that, I mean, IWEC and obviously TACA, that is gradually committed to retire the plant. SWPC, who has only one desalination plant with MSF and successfully retired, or is in the process of successfully retiring it. And obviously Etihad We that have a number of MED plants, but now I understand they are in active standby. So thoughts, first of all, the experience in how feasible, how practical this is, and I would like to have your thoughts about that.
We have one plant currently under construction to replace a thermal plant. This plant is 880,000 cubic meters per day. Once this plant is shut down and it's replaced by the RO plant to produce 600,000 cubic meters, the CO2 reduction from that plant alone is 9.7 million CO2 reduction. So this plant, I think, yes. This plant is one of the largest maybe in the region. We also have another plant that it is an RO technology, but also of oil-fired acid to produce electricity. But to be specific, as a desalination plant, this is the only one SWPC currently has. And this plant is planned to be shut down in May. And we also have the project manager here today that can add more details. Maybe in his session tomorrow he will go in more details.
Margaret, can you give us a mic? We'd like to hear more on this experience. Yeah. Can you just, before you introduce yourself?
Assalamu alaikum. Good morning, everyone. This is Mohammed Al-Qahtani, Executive Director of Project Delivery from Saudi Water Partnership Company. As my colleague, Mr. Suleiman, illustrated, I am currently overhauling and supervising this plant conversion to be replaced by a sustainable new RO top technologies and innovation implemented in this plant. And as my colleague Suleiman illustrated, there is a lot of sustainable solution. The idea conversion is itself, it's very good idea, to be honest. And we expect to save just from the fuel around 60,000 barrels of oil equivalent per day from this plant only while we're retiring this. Also, as a carbon equivalent reduction, it's around 9.7 million carbon reduction will be avoided to emit into the atmosphere. Also, the complexity of, as you know, all of you know, in the operation and maintenance of thermal desalination and MSF and the boiler and the steam that is dumping to the condensers without and complexity of operation as general. It will be also transfer. All of these efforts will be transferred to new RO, and this RO is 600,000 cubic meter per day. And also, as you mentioned in your beginning, the demand itself is driven, and it is feeding holy city, which is Mecca. Inshallah, we expect the project commercial operation date to be in May, and we anticipate that it will be, inshallah, much earlier. So this is much detail. This is some details about this idea, which I salute actually this idea to be followed in the region and in the other countries.
Thank you. And I guess, yeah.
Maybe from Engineer Mohammed answered from a technical perspective. But your other part of the question, does it make sense for the investors? This project was on a commissioning period, concession agreement up until 2030. So it made sense for both the government and the private sector to decommission this plant. So the saving from oil purchases from now until 2030 is 21 billion Saudi riyals.
So that is
From oil
it's a good
purchases
combinations of
Absolutely.
sustainability targets goes along. It does not necessarily fight
Absolutely.
with the fact of having a useful and convenient and economically competitive tariff.
Correct. And to be fair with the private sector, the deal was structured in a way that the investors do not lose on the concession. So the deal was structured that they would still receive some sort of compensation up until that day. And the plant that will be commissioned in May will be in addition to the previous plant.
Kartik, you see that you wanted to intervene on this point, yes?
Yeah. Thank you. Just to add, it's no secret that RO consumes 1/4 of the electricity as thermal desalination. However, there is also a strong focus in the region for decoupling the power and water assets so that we can utilize renewable resources to feed the desalination or the RO plants. As you all are aware, the requirement for water is almost constant or consistent throughout a year, whereas the requirement of power varies between the seasons, summer or winter. Bringing in renewable sources of electricity to feed desalination plants and decoupling power and water is helping a lot in energy efficient solutions and increasing the sustainability. There is a commitment to reduce the consumption by 60%, and we also have a commitment to make it more, I would say, transform 2/3 of our water capacity to RO. Not only that, when it comes to also transmission and distribution, I think this region is setting an example of the lowest losses. Average is around 6 to 8% here in this region, and compared to a global average of 30% of losses in transmission, and we are targeting to make it even better as much as possible. So I think.
And sorry to interrupt you, this is something that I would like to emphasize also for the audience. Let's say there is a difference of 20 kilowatt-hour per meter cube between reverse osmosis and thermal desalinations. So you summarize this 20 kilowatt-hour per meter cube in oil saved. And what is the missing revenue, even from an economical point of view, on miss sales of oil? And that's why I guess it is important to consider this one. And I think what is important to say, and this panel is bringing is to our attention, is that there is no contradiction between being sustainable and making money, and having a real sustainable aspect in the technology. And in fact, I would say, as soon as the energy intensity in a desalination plant start going down from 5, 20, 25, and now 3 kilowatt-hour, also the tariffs start going down. We saw the example, for instance, Rabic 3, it was the first one, 0.5 and 3.2 or specific energy consumption. We saw the example of Al Quwain. So that is an important aspect. I think, Abdallah, I don't want to ask you how Etihad, former FIWA, got rid of the MED plant or keep them in strategic reserves, but you were one of the first one to do that.
Yeah, exactly. So just to shed about it, I will take it maybe from UAE perspective. We are seeing, most of the investment, the desalinations or production facilities happening here in UAE. Majority of the development was late 90s and beginning of 2000, I would say. And we are, I would say, we are on the lucky, that we are not losing anything as of now, because if we are retiring because of the aged assets. So We don't need it anymore because it's become inefficient, and even, the IWPPs, which was signed earlier, is due for expire, and some of them already expired and under extension as of now. The other point, we are shifting, toward the RO on the right time when I would say the technology become more mature. More mature meaning the term of the product, in terms of spares, in terms of big scale, because it used, to be utilized in olden days, for small scale only, the reverse osmosis. But as of now, it is widely used and can be used, for big scale. Talking about Ittihad, since 70s, I would say, we are utilizing the reverse osmosis. And mostly, for brackish water and this type of applications. Later, when we developed maybe the MEDs, MSF, in our plants, we were requiring, the energy. That's why, at that time, the best actually, the combined cycle and conventional, thermal plants, it is the solution which have been seen, as a requirement and would help the purpose because the electricity demand always, continuously there and always stable. Now, when we shift, toward, the renewable energy, of course, during the daytime, you have to curtail, the old plant. Then what would be happening? You will be impacted through the water constraint.
Correct.
To overcome that, as my colleague, said, in Taqa, they start, decoupling, introducing the ROs. In Ittihad, we stopped all using of all MEDs and MSF some time ago, before even, Naqa, but by Naqa, we have decided clearly, that we are not anymore need, to have a supply, through the MEDs and MSF, and we stopped all of our plants. At that time, even, before we stopped it, even before that, because we were getting a secure, water through EWIC from Abu Dhabi, because there is a transmission, network in Northern Emirates. We utilized it at that time, for us in order to have a water, not from the thermal, rather than getting it, from their system. So this is the phasing which we have gone through it, especially in Ittihad, and we see there were no any loss for us in our previous investment, and now we are investing in something that giving back good amount of money. Of course, it's required, sort of investment, but again, this is a requirement, and we have to go for it.
That makes a lot of sense. And you said something which is triggered my attention, the fact that we start investing in reverse osmosis when the technologies start being mature, no? And this obviously still remains one aspect that needs to be considered at large, because I remember in May last year, just 2 weeks after the big flood, there was an emergency here in the Emirates. All the desalination plants, so they struggled. Etihad, we managed to maintain the productions, but obviously replacement rate of the cartridge increased because of the red tide. So efforts needs to be still paid to make reverse osmosis more resilient, I guess. And there is one aspect that is very important. Thermal desalination plants were a know-how. You buy an MSF or you buy an MED, is like you buy a Siemens machine or a GE machine. Reverse osmosis is a technology, so basically it's an assembly of components, and everyone can design plus or more or less conservatively. There is always ways to cut corners, and therefore it's important that the engineering is done. It's shifting from a know-how to an engineering aspect. But as I said, the advantage is here, and what I see is a continuous and tremendous decrease in energy consumptions. We were talking 3.5 as an impossible threshold 6 years ago, and now I mean, Rabic 4 is 2.7. I mean, I like if you can explain how is it possible. And 2.7. No, I know how it is possible because we are the only engineer for this plant. But maybe you can.
I will try to not explain it in a technical way. We have also competitors to the Rabic 4 developers in the room, so I will not go into technicalities. But from a non-engineer's perspective, I'll just go through it very quickly.
Yeah.
I'll go first through the history. During the early 2010s, the power consumption for desalination plants, which usually were MSF plants, was in the threshold of 7.6 kilowatts to produce 1 cubic meter of water. We put mandates in place 6 years ago, like Dr. Corrado just mentioned, 2018, to the threshold of 3.5, and then we reduced to 3. Today we have Rabic 4, which is under construction, a 600,000 cubic meter per day desalination RO plant. And power consumption is 2.53 if you incorporate the PV in it. The reduction in the energy is mainly due to 3 components. An advanced energy recovery system, which is key to reduce the energy. Second one is a smart flow distribution system. And the third one is the installation of 7 megawatts of renewable energy. Dr. Corrado knows, I think, all the secrets behind the detail of this. But from a high level, it's mainly 3 components.
3 components. But again, we have here in the UAE, with worse water than the Red Sea, the Al Quwain plant, and we did the annual capacity test in July, and we recorded an energy consumption of 2.9, which without PV, which is phenomenal. So, and considering that this plant was designed with the criteria of 2017, so there was no such competitivity. So, Abdallah, tell us about this plant.
See, the expected tariff, when it was set at that time, it was around 2.98 kilowatt per meter cubes. But we have seen, because of the technologies, we are able actually, to achieve this target and more as well. So like pressure exchange, variable frequency drive, okay. But at the same time, when we start operating, as of now, we have a saving, okay, in the energy. Okay, the energy is coming because now the energy, most of the energy consumption due to the DAF operations, So when the DAF not in operation, this with the DAF in operation, it's become 2.98. When the DAF not in operations, then we are also saving more. So I would say here from the technology itself, adding solar maybe would add more saving. But at the same time, you need to assure, the integrity, of the solar within the system and how much reliable you can rely on it, during the normal operation, because it will be up and down normally the solar system. But again, no doubt about, that would be adding more value and would be adding more saving, for the overall energy consumption.
Yeah, this is important what you say, and I would like to pick up Kartik, mine on this one. Saudi has allowed the installation of solar PV within their premises, and obviously this has increased the energy consumption, the energy efficiency. UAE, the only experiment was Tawila, but the two situations is a little bit different in the sense that the UAE grid is mainly supplied by nuclear and solar, and the carbon emission factor is only 400 grams per CO2 or per kilowatt hour. Whereas Saudi Arabia is still heavily relying on Arabian crude oil, fossil fuel. So the grid emission factor and the cost of energy is much higher. So maybe you can elaborate a little bit on the difference between the two philosophies and why one applies to the UAE and one applies to Saudi Arabia. and how at large this will.
Sure. Maybe just to start with the basics, you can talk about specific power consumption in two ways. One is the base specific power consumption of the plant without any optimization by adding solar or renewable energy to reduce the specific energy consumption. And the second option is to add renewables and reduce the power consumption. There are different models, obviously, as Dr. Korada has told. Earlier, if I believe correctly, UAE explored the model of Tawila Arvo, where there was a 69 megawatt or 59 megawatt peak PV, solar PV plant, which reduces the power consumption. But later, as things developed further on the renewable front, you saw plants like Dafra PV1, PV2, Shwaihan, huge projects, 5 gigawatt projects, 2 gigawatt projects started coming up in solar separately, plus the addition of nuclear. So I can't talk on behalf of the policymakers or EVEC for that matter, but I think this opened up an opportunity to look at keeping the renewable part separately for grid to contribute, but look at how to optimize the energy savings in the plant itself, in the base model itself, be it with energy recovery devices, be it with certain new technologies. I think it also adds a lot of pressure to developers and the manufacturers, because nobody wants a plasma TV every time. If it becomes an LED TV, they want to go to an LED TV. So the manufacturers also has to constantly look at how to optimize and make the consumption lower and lower.
And this obviously emphasizes one aspect on the policymakers. If, like 10 years ago, the price of energy was $0.5 per mega BTU or gigajoule, nobody was interested in having an energy efficiency system. But if now the price is 22 dirhams or 22 fils or 18 alala per kilowatt hour, and then energy becomes an important component, and therefore you go into the energy component to optimize your cost. And that is the difference between a good policy and not a good policy. So a policy that is subsidizing the cost of water through subsidizing energy, whereas in this case we can have different things. Mr. Bandar Al-Samari, I really would like to have you here, but I'd like to ask you a question. NWC was one of the very first adopter of reverse osmosis for all the well water in Saudi Arabia, and you had a very, very large fleet of plants. I guess you are facing now all the challenges of deep depletions, non-renewable water, increasing salinity, and brine disposal. And obviously this poses a lot of pressure as well on you. And how is NWC strategy in respect of all of these?
Thank you, Dr. Corrado. Yes, thank you so much for this question. And please allow me to extend the appreciation for the organizing this conference. Actually, just allow me to go to the main topic of this panel discussion, the strategies and policies. It is something not rigid, something has to be reassessed frequently and to be improved. The challenges which are facing a distributor of the potable water, it is really coming from the consumption itself. So the higher consumption of the potable water in the households, that made us as a distributor facing a lot of issues, either to enhance the quality or keep the quality to the limits that is really, we are strict to these limits as a quality, or to the amount of water as a flow rate has to be received by each consumer on that properly manner. But one of the good experience I would like to talk as a global, what's happened in the Saudi Arabia. So the Kingdom of Saudi Arabia, which was the biggest country in the GCC countries, that are facing the scarcity of water in very strong strategies and policies. That led the national strategy of water being formatted in 2015, 10 years ago, based on a very prediction of that demand. The demand was in 2015 reaching 25 billion cubic meter of water. Out of that 25 billion cubic meter of water, 84% was coming from the agriculture itself. So to manage or to mitigate the risk of higher consumption, we have to look at the higher consumer. The water sources are coming from the desalinated water from the seas, where we are having two sea coastal sites in the Red Sea and in the Gulf, Arabian Gulf, where we are having the higher TDS. So that made us also to look at the groundwater itself, as it is non-renewable, the groundwater of the deep wells which are in operation to improve the quality, or sometimes to fulfill the requirement of that consumption. All of these challenges lead NWC to maintain the quality, to look at the reuse of water, where we are having also in our surface mandate as NWC to collect the wastewater, treating it. So the journey of mitigating that higher consumption didn't stop up to the water meter which is connected to the households. That's connected to look at where the consumption coming from the agricultural use, improving the environment of reuse of that wastewater. And that's why we have very strong initiatives coming, like a Green Middle East, Green Riyadh, Green Saudi. All of these initiatives, all about reusing of the TSE water, the treated sewage effluent. We hope that based on that strategy, the continuous of managing the consumption will be going to the proper approach. And as I said at the beginning, the strategies and policies, it is in the formatting of all of those water organizations in the kingdom. It is more than 8 organizations. All of it are working, working as very proper way to make it strong, organized between all of it. So the strategies and policies under continuous improvement, and any challenge will be appeared in the horizon that has to be regulated, have to be mitigated in a very proper strategy and policy. Thank you so much.
You raised a very good point, and I think it is worthwhile to mention the fact that TAC reuse is not only an option, because it becomes a threat. Whatever we had in May in the GCC, which brought about this significant curtailment of the production of water, was due to the fact that the TAC was not reused, was dumped in the sea and generating a eutrophication of of the water and a sudden, really very, very, very severe algae bloom. So again, this is another example, in my opinion, how we can combine a good policy which is environmentally sustainable and at the same time, in a holistic way, save money, because all of these activities cost a lot of money. And this is an example of how, for instance, the desalination industry invested a lot on dissolved air flotation. But dissolved air flotation is necessary for oil spills and for algae bloom. But algae bloom happens if there is an excessive eutrophication of the water, which is caused by dumping TAC. So right policies shift the industry towards a virtuous rather than a vicious cycle. Can I have 1 minute views on from all of you?
Having policies in place, I think it's part of the puzzle. But commercializing this is the challenging part. Today we have 4 plants that have infrastructure in place, that have pipelines, TSE pipelines, roughly between 15 and 35 kilometers each. The total capacity from these 4 projects is roughly 700,000 cubic meters. All of this TSE reused water is going for either agriculture purposes or it will go to the industrial purposes. The majority today is going to agriculture, and we have plans in place for additional 6 TSE projects that will have, STP projects that will have a connection of, yes, TSE, and all of this is under the PPP model. You would have other policymakers or utility providers that are doing this on an EPC basis, but we've proven that the TSE can be also commercialized under the PPP model.
Abdullah or?
Yeah, just to highlight it is, as you said, TSE, it is very important actually to be used, and the important is not just building treated plant rather than utilizing this in the network. Plus it has to be in line with the expansion for the water while we are expanding more, and the growth is growing in the community. So we have to cope with that growth. So what is happening, maybe in the earlier days, we have already built treatment plants with a capacity at that time, but we never think about the expansion and the growth, because they are just running the plant at that time, small network, to distribute some of the treated water, and the rest they dump it in the sea. But we noticed it, we noticed a lot of impact on the environment on the marine environment, even with our desalination plants, where we have proposed, to have more and better efficient, treatment, that having enough capacity actually to treat the whole quantity of the sewage, plus you have a way actually and a network in order to utilize whatever being treated and distributed to the agriculture or industrial area and utilize it in an efficient way. Thank you.
Yeah.
Sorry, I have not many points to add here, but not just TSE, but also in terms of brine management and in terms of wastewater management overall. I think there is a strong push from the policymakers, because every plant I see, they have a different instruction for changing the technology as per the requirement. And also as a developer, we are putting a developer hat here. We are also more focused on sustainability and trying to ensure that we give what we have been asked for, and over and above, we can do something more like brine management or additional things that will make it more sustainable.
I'd like to finish this panel with a view, and we are not doing desalinations thinking of simply supplying water to people who need water for the public use. We are doing now a study for the World Bank, whereby if the desalination energy footprint is 3 kilowatt-hour per meter cube, and the GAF3 takes 5,000 liters per year, you will introduce in the atmosphere 10 kilos of CO2, but the GAF3 will take out from the atmosphere 25 kilos of CO2. So maybe desalination is not going to be only a response for water scarcity, but is going to segregate to be the response for the overall climate change at large. And with saying this one, I would like just to please acknowledge the fantastic input that we received from our panelists. And if you can please stand up, Mr. Shamari, also from Mr. Shamari as well. we would like really, you have done really great contribution today.